Alright guys, we're live again. So I was actually streaming and I realized I had not been talking. So I decided to end that just for anyone joining in, not to think that I'm actually mute or true. And that was why I had to end the stream and restart a new stream. And we're live, we're back again. I do apologize for that. So essentially I'm working on this define function macro, which I'm going to show you guys again. And what that does is so what that basically does, if I let me show you real quick. So you write this function, and this function is embedded within the database instance itself. So you'll be able to use it if you like SSH into the database instance, or you're using like your GUI. So not just from your code base, right? So the idea is that you write this function, you define the function. In this case, it's called getParser. You have a bunch of arguments, then you have your function body, right? Which is cool, right? And at the end of the day, it actually spits out two functions. You get the function which you can use within your code base itself, the getParser function, and you get the getParser statement itself, which you have to run against your database first in order to be able to access that. All right, I'm back. So the beauty of this is that you run this against the database, then you'll be able to access the function, right? So it spits out two. And actually, in order to stay consistent with other inbuilt functions defined by SurrealORM, I'm looking to make this a macro instead. So it's going to spit out a macro and a regular function which you have to run against your database in the aggregator. We'll get back to that soon. So essentially what we're trying to do now is move this implementation from a macro rule. As you can see here, it was previously defined as a macro rule, and we're trying to move this implementation to a procedural macro to give us more flexibility and just more robustness. So the idea is, as you can see here, we've got like the function name, the identifier, we've got a set of arguments, and sort of takes that as a bunch of we've got a bunch of statements followed by the return return statement, which it should end by there. But another benefit, extra benefit of what I'm moving towards is that, well, a function doesn't have to return. For example, you could create a function that just maybe creates a bunch of resources or like any other stuff and not necessarily return something, right? And that should be valid. And you don't necessarily want to bind every expression to a variable, right? And that is another reason I'm moving towards this implementation. Another benefit is, right, rather than you writing something like this, which is not bad, right? You would be able to essentially write something like this, which in my opinion is cleaner. You know, you write the if-else statement as though you're writing a normal Rust if-else statement, right? So where we're now, basically we're writing a parser for define function statement parser, right? However, we're having an issue because we cannot when you're using this question mark, you're trying to implicitly convert the current result to the returned result in this case, right? If we check the parser, it has a type results with the error. And what you're going to notice is that when you implement the trait, so the parse takes f like a generic argument, and f is bound to a from string trait. So when you implement from string trait, you're going to see that f returns the type which you pass as generic, in this case field type. However, the error would be of the associated type that is used in the implemented side of the from string trait. And what do I mean by that? If I go to the definition of field type and if we go to from string, right, as you can see, in this case the type is going to be field type and the error type is going to be string. Yeah, so it means in this case results, this is just for explanation purpose, this essentially would be the result type, right? And in this case we're expecting a scene result which is not the same as the standard results, and this scene result returns, well, the standard result and error. So I don't want to go into the definition because it might slow down my editor a little bit. But anyway, so one way, let's just make this work first. So we can do that and do this, right? Yeah, and that might be okay by you. Alternatively, you can also do, let's say, you just match the type, and you say if it's that, otherwise if it's error, just gives you this. Let's see how we've used this elsewhere. Scene error. We've been using span score site. You know what? We're just gonna do that for now, just to get that out of the way. Probably that. Oh, let's comment that out also. Yep. So let's see the usage. Scene error. Okay, that's just new. So probably so we take that and we convert it to string, and then then we use the parser, which uses num parser, and so that's the field type parser. Then let's implement parse for that then. Parse implement missing member. So this is gonna start with the identifier. So let's split that into two, and let's look at how it's gonna look. So first, well, the function name, right? We start with the function name. So we press the identifier. Next up, we add aux content. So this would be parenthesize. We have something like this in the if else statement. something like that there. So we are going to parenthesize that, and this is going to give us the content, and the content is just going to be a bunch of, yeah, so this takes the arguments, and which we should implement a parser for. Actually, the argument separated by comma, right? So we need to implement parse for argument also. I mean, we could have a while statement going through each and every one of them and parsing all the arguments and stuff. But you get what I mean? You mean what I get. So let's implement parse, and this gives us the arguments. From that we let's see what this is gonna look like. Alright. Yep. Anyway, so we get that. We're still gonna implement that parser, and after we've got the argument, let's go a little bit. Then we got the body. So the beauty of this is we can steal the body implementation from the if else, and that is cool. And we can just then go, okay, give us that. Let's import that. So we get the parameters, and so we get everything pretty much that we need. Then this is gonna look like e.g. arguments is just, yeah, but you could also have like a complex type. So essentially a single argument, the first is gonna the argument, then the token, then we get a type, which is gonna be this basically, and that way we can get okay, yeah, we get that, you get a gist. Let's see. Yep. So we've written the parser for that. Let's okay, so now we've got the arguments and all that. So we would have to tokenize it also. Why is for loop? What is for loop doing here? Actually, this should be if else. Yeah, this is relevant if we're trying to have an if else standalone statement, which I don't think we try to, or we try to have. So anyway, what else? Let's check query chain, query parser, I believe for loop if else, so we're using that here. But define function is going to be like a standalone statement. So yeah, we got the parser. We're going to tokenize that also. So why don't we go ahead and let's it's going to be a little bit different, but we could just create this. Probably we could create this as a thread itself, and so we can do implement define statement parser and just take that, you know, I could probably reuse this definition. For example, this could be a generic stuff. It doesn't have to be just if else statement, but let's copy that and let's call this I'll just start making it generic now actually, and this would be self and yep, yes, import stats is map 1 or 2. So essentially what we want to do is take that out of the way, take that out of the way, ooh, yeah, this is going pretty nicely and swiftly. So you know what, let's check. We can take away that. How is this used? I should have a definition. Okay, that's a test. We can take that away also. Let's go to define function builder to the there. So essentially we just define, we pass the parameters. What's the definition of param type? String. Maybe that could be improved actually. Field type would be more appropriate, but we can leave that in a minute. No, I don't think we should actually. By the end of the day, it's more like if you know what this is called, a phantom data. In this case, we generally don't need a param type itself for the functionality, because we are defining the. I take that back, because I don't know. At least prior to this, we didn't need it. We didn't need this. But in the new scenario, I'm not sure if the database now requires this. Regardless, there's absolutely no reason that I can think of right now why we couldn't just make this like field type, or like something like this, right? There is nothing that comes to mind as to why we couldn't do this. And let's see the way we're building it. Then parameters. Param type. Where will we gain the param type here then? It's coming. Oh, let's see what param is like in the first place. Params. Okay, that's interesting. Oh yeah, we're taking it as a tuple, which makes sense. But anyway, there I think having field type probably makes more sense here. Yeah, we can just do, maybe we can do this as I did have it before. So we can map this. You know what, I could do one second. Yep. We're back. We're back. We're back. Guys. So we're switching that to field type, right? Because I actually don't expect you to write the function using do the define function statement just using this raw stuff. So perhaps we don't even need to stress with this. Done. Let's remove the iteration and let's go there and change that to field type. Done. We can change that. Yeah, in the old definition that might be problematic. However, we're switching things up, so it's probably okay. Maybe. Because anyway, we can't use something as simplistic as that for the type anymore. As you can see, previously we're using the type as an identifier, but it's actually much more complicated than that now, because you could have a type like prior to that we only had like simple types that could be declared as almost like an identifier, but now you could have like types as I showed you earlier. You could have an optional type of an array of string of size this and much more complex, and in this case this wouldn't be like representative of it. So what we actually want to do, this won't cut it anymore. So this wouldn't just be an identifier. In this case, it's just gonna be like a bunch of some tokens and stuff. And I think, not even just think, it's evident that this will serve us better, because you see we have the field type parser. We checked into these and we parse it with our own special field type parser, and then we return that. So this is more robust in my humble opinion. So but I guess the problem with that is, okay, maybe not, because we have a delimiter. So anyway, so here we go. Let's close that first. Let's close that, maybe close this also. Let's see how we're using it here. Define function, the function name, we pass the parameter, we pass the body. So essentially we're just gonna copy all that, and let's, you know what, let's put that right down here. So what we want to do now, the parameter itself, okay. We stringify that. Use the field type. Yeah, this would be create name. Yep. So we're gonna get that the field type. So we already have the body, and I think we can just do body and it doesn't even have to be a block. I don't think so. But anyway, we want the parameters in case you want to reference it from within the code. Then the field type when you're creating the statements. So yeah. Yep. um, perhaps rendered. That's what we're trying to render. And yeah, that's it. And code actually no, do it that way. Field type parser. Field type parser, I was talking. So we get this and we're stringifying it. I actually don't think we need to stringify it anymore. But for what we want to render, we don't need to render the type because we just want to take that in. Then this gives us the name. And yep, that's probably good enough for that. And we can use that. Yep. And I believe nah. See if we got something like that here. Yep. So I would look like that. Render the parameters. Then we don't need this anymore. Then we also need to or don't we? Actually, we don't need to bind because if we instantiate all the parameter, we just need to reference those. They are ephemeral variables, so I don't think we need to even bind those. But I'll see about it. Do we need to bind them? But we have this part. What can we call that? Ads. We can call it that. essentially we're trying to get I'm actually gravitating towards using struct there rather than tuple, you know, just to reduce confusion. Let's scroll up a little bit here. It's, you know, and maybe even call this args. And then we can do struct argument. Let's call this parameter. We can call this field type. Yeah, basically overhauling that argument. The downside to that is then, okay, maybe we can rename this to function argument. Now we have to export that. Okay. Yeah. So yeah, we could or would you want us to go with the tuple? So we got the name and we got the type. So this is gonna be name. And this is gonna be type. So we're getting all the arguments used as token stream. And the type is field type, right? So we'll go through each of these parameters. Gives us this. And I'm actually contemplating taking this as string so it's easy to work with. So because alternatively we can do this and implement 2 tokens if we haven't for field type parser. You should complain because we haven't implemented 2 tokens, but anyway, we can then implement 2 tokens. Yep. Yep. Essentially what we can do is we get the type out, take it to string, and we parse that to string. So I mean, if we want it in the raw type, right, what we can also do is we can do like dot parse field type or wrap. That's definitely something we could do. We just have to decide if we want to do this at the color site or the implementation site. So this is going to give us a string representation of it. So if we go down here, and alternatively we could just implement to string by just delegating that. Let's see if we've got the delegation to string. No, we don't, but we can implement it and just call it just implement the display for it. So we do display and basically we take that type and just implement the string for it there. So something that we can do is take the string representation of this and have it here, and here we can do like parse this and like expect invalid field type. So that's definitely one thing we can do. So this gives us the argument used, and okay, this is an identifier. So we also want this to be a string, which we can convert into param here. So we take the axis here, we go down. So rather than having what we've added here, we can just do this, and actually we wouldn't need a vector here anymore, would we? So I've used, let's collect that. Well, that is gonna be at compile time, so what we can do is used back. Yep. Then we pass in the body and the function name. And actually I don't believe we need this part anymore. We don't need that part anymore. Yeah, a second. I don't think we need that part anymore, so you can take that off also. And can take out this part. Since this is like a standalone statement, let's see. So this will, and now this is actually called args, or should I just call it arguments? let's just call it arguments. Right, let's copy that. Arguments, and this whole thing is define function statement. That's just the first part. We also need the second part. So this is a statement, but we also need the function itself, and I actually want that to be a macro. So let's check that out. If we go to the previous implementation of this, you would see, okay, this should also change. So if we still want to use that, it's gonna be function argument. Let's change that, and this would be name, and this would be type, like that. So we're spitting out two things. We might still need this, but let's we can copy this. So we wanted to also generate a function called this. Let's go back. Let's call this generated function def name def. Just gonna code that. Maybe okay, let's go back there. Let's copy that. Okay. So the function name, we don't need paste there, because we can, this is procedural macro, we can do whatever we want here. So let's do the generated function definition. Yep. So yeah, we wanna the function name, right? We have that, and we can take this away. Maybe take that away. So yeah, we have the function name. And what we can do we have the function name there? Yeah, we do. Okay, then we want to generate the parameters for that also, and that should return a function to use the create name, private bindings, blah blah blah. Let's see. Create name. So this we're generating the statement itself. You can just say function statement name, and from do we even need the outer part? I don't believe so. Function name, argument used, the body, so for the function name itself, for the argument, so when you call the function, I'm actually looking at, like, let's look at field type definition. You've got all these field types. So one thing we could do is, like, I want you to be able to type check. So let's say you create a function called, I don't know, it's called get user, right? So you get like get user statement and get user function, and now you need to call it again. So let's say the function definition is gonna be count, I don't know, and that should be an integer or a number, right? So when you want to call this, is gonna be like get user, and you can put 56, right? But you wouldn't be able to do something like this. You wouldn't be able to do something like wrong input, right? Because it should take a number or integer. So one way we could, there are like two approaches that come to mind. First, like we could implement a mini transformer that takes the string or the type and creates a converter out of that, right? So I've got this something like that here. So it sort of takes anything you have here and maps it into a different data structure. But the problem then is when you have something more complex, how do you handle that kind of scenario? So I actually have an idea. I think this is gonna be a good idea. So one way we could approach this is we can say you can create a method and call it like it's a simple data or it's primitive. And when it's that, we just use this basic or simple transformer. And then otherwise we just default to value like. So it's gonna be like generic value type. Or alternatively, we can just tell you to like pass in the field type, in which case you're gonna use this, right? um so what would be a good balance, you say? So I think one thing we could do is we could still use the mapping. Let's take that. Let's use the mapping. Then let's go from here. So we're gonna have the type, which we can parse at compile time. And actually the beauty of that is we can do field type mapping, and that's gonna be params. Let's just take that for now. So the beauty of that is we can do like match type, and then we could just fill it up, and we could take a clue from this. Yep. So let's take that. So if it's an array, we can so this takes value like bool, like date, like strand, like number, like number, like probably can be improved. I should probably create like float, like integer, like, but we'll leave that for now. Object, like thing, like. So I think we can just do that. And for array also we could, because I mean we could use like recursion here. We could use definitely recursion, but maybe we want to keep it simple, right? Maybe we want to keep it simple for now, and also keep this simple. I'm thinking if we should use recursion, so you can have like a clump, you can do a little bit more complex definition, and there isn't a custom type. Okay, we've got null byte, feel that. I'm not sure we've got null, like. If we don't have it, I can implement that. UID, like. This is gonna be a little bit interesting, and I'm actually thinking. In the case of option, okay, we might want to keep it simple, right? So what we actually want to do first is so what can union look like? I think for union for now, also for union we could just we could value like that. And for set, for now we can use array, like. Should we create, let's see, array, like. I'm thinking if we should also create set, like. You know what? I'm just gonna do set, like, and keep it simple for now, and it's gonna be array, like, for now. So call that set, like. Let's do that. What else am I missing? So call that set, like. Is that being exported automatically? Let's check. Data types, here it is. So we have value, like, for union. For option we have option, There also, I'm just wondering if we want to do anything recursive here. In the case of like array, I would also want to be able to pass programs and vector and all that. So let's keep it simple. Like, I think we can keep it simple first. No, what did I do? So this gives us the type, map type, so we need a map type. The map type is used here. And what we're gonna do is we're gonna put that here. Oh. Yes, so what are we missing here? Field type mapping. Oh, that's a vector. So what I want to do actually is I probably want to create a function to do this separately. Yeah. So we've got the generated function definition, and I was actually thinking if we could make this as a macro, and it does seem like a function should be prefixed by fn. So that's something to keep in mind, like something like this, but I'm gonna have to confirm that. Let's confirm if custom function has to be prefixed. So all right, so we've got that for the function itself. Let's see if it makes sense, or if we could even make this into a macro. Yeah, let's see. and the type is gonna be so um so what could this look like? Yeah, so we can actually just take that. Let's create a block. So got that identifier. Okay, actually I don't think we need a type here, because for example we can call this like get user, let's say it takes 3 arguments. I want to call the macro, we can take 56, 74, username, and you get a part, you get the gist. So we only need the maybe not even an identifier, we just need it's like a liter type or expression actually. So can we check it through? So is the type coming from there? So let's see what we had here. So essentially we're taking the type, basically from there. Could we do something like this? Let's see. maybe just this actually, and go down a little bit where we go bindings and builds. Let's try to do for the type. Will this work? Where did two tokens. Take that apart. So what that is saying is essentially this even though we can actually do this with not in macro rules. What this is saying is that, as you can see, this is as a slice, an iterator of this code, and it's saying that let's see, it's not satisfied to tokens. It's not satisfied. Yeah. So basically, we don't have implementation of two tokens for vec of token stream. However, we have these for a single token stream, but not for all. So I'm looking for how to make this work in this procedural macro. Yeah, would be a good way to make it happen here. to be checked. I think I have an idea. I have an idea. Um, but. Mm, um, mm, I'm just thinking if we could take all the arguments, what we can then do is take all the mapped field types and we but those are types we cannot iterate over them since those are types. um no, I'm just gonna do something like this first. Create name value like lookup bindings and build clone. So actually I did make a mistake earlier. Let's see. I don't expect that to work though, but let's see again. So that was this isn't what we're trying to do. I mean, technically that works, but is that what we really want? No. So it's actually quite hard. So this isn't exactly what we want here. Where's the name coming from actually? Name. Okay. Oh yeah, it's just a local variable there. So I'm just trying to check the parameters against the types. I'm thinking of what would be the ideal way to do that. That's essentially what I'm trying to do now. So um, um, yeah, so I'm thinking, what if we aggregate all the argument types here, and let's say we get args that um mapped Okay, yeah, I think I have an idea. Let's do it that way. Mm, so we'll go to the argument. Get to the arguments. We iterate and enumerate. Then we have the index, and the index should correspond with the position of the argument. Then we take that, and this gives us a type, right? So essentially what we're trying to do is get the integer types. So so we get that. We can actually just use a for loop here. So we can do oh my god, we can do a for each, or like let's just do a normal for loop for ag in x. We can x it could we just enumerate it right away? So this would be sorry. We can say that should be then we can have the private binding, and we can have the we can just remove all that. Actually, I think shouldn't this be let's give some time to load. Yeah, so we just go over the arguments and we get the corresponding type. We try to um, convert it into that type. We extend the argument and we also build it. So that looks okay to me. We wanna return. We actually want to return the generator statement itself. So I'm thinking I'm gonna return talking string. 1 second. I'm trying to use my drugs. I'm back. So we're just gonna return token string right away. So then we would have to, yeah. Do we want to have a dedicated for loop? I don't know. I don't think so. We haven't tested the define function, but we're gonna do that. First I need to check this. We'll probably just do away with this old thing. Oh no. Yeah, actually I should be committing my code. That's not nice. So what else do we need here? Yep. 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 Within the block, we can actually do something that if the last expression is the last token string, then there are two ways. You can either parse as a return statement, or um, you don't have to deal with the return keyword. Basically, the way Rust works, I believe SurrealDB engine works the same way, in the sense that you can either say return, let's say 5, then semicolon, or you can just say 5 if it's the last one. We can definitely support that. We sure can support that. So we need to just check out define function and see if it works. We have an example example usage here. So let's see if it's okay. It's exported here. Let's go here. Define function. What else have I got? Okay. I believe that's everything. We could do the same thing for if. Have an if standalone if statement, but I'm not sure if, like, why would you want to do that? Anyway, so now that we've got that, we can safely remove this 6. For this test, we can we can move it to the integration tests. define query define. Okay, we already have it. Yeah, so something like that. Let's comment that out first. Is there a way we can bring that? Actually, let's just leave it as is. We'll come back to that. Okay, this should now be a macro if it works. It should remain a function. Let's see. I'm just gonna restart my ID just to be sure everything works. Just like let's see if that works. Just to be loading. It's still loading. Yeah. 1 second. So we've implemented the five functions. We just need to make sure it works. That's what I'm trying to do now. The five function should be there. Expected a valid field type, but surely string is a valid field type, isn't it? And that should be a macro, of course. Let's try to expand that. Expected a valid field type. So that doesn't work. Okay, interesting. It's giving the whole thing and I'm expecting it to give just one. Because we're using it here, right? Actually, you know what? I think I have an idea. Last that. Okay, so this includes other stuff also, including the punctuation, and that's why it's not gonna work that way. Oh yeah, even though we're pressing the type, we're not advancing it. We should advance that. case will be a little bit tricky. Cause like just think about if we have like arguments, like first let's say it's just string, and second is like option array integer size 5, and third is this, like you couldn't just say comma separated, you actually have to parse everything properly. So I mean, alternatively, I could tell you to just like pass in the actual type rather than the like for example, I can tell you to pass in like field type. That's not gonna cut. That excuse me. 1 second. That's not gonna cut it because it's gonna be that's gonna be an email. We couldn't naively just say split by comma, then that's not gonna work. Just thinking what would be the most robust way to handle this case. Now let's just Let's see if that's gonna cut it. Let's see, I'm doing that in where am I doing that? There. We could also just try a while loop and Yeah, I've installing way too much, but I have a plan. But according to Mike Tyson, everyone's got a plan until they get punched in the face. But yeah, today has been my recovery stream. As some of you may know, I've been a little bit ill, actually very ill, for the last couple of weeks, and that's why I've not been streaming. So I may be a little bit slow today, but I'm back and I'm excited. And I can't wait to finish this. The plan was actually to finish this last week, but I got sick, so we'll have to shift this a little bit. Once this define macro function is done, I just need to add a couple of tests for the query turbo define function. Basically, just add some integration tests for that, and this PR is ready. And after this PR, pretty much, I would say this project is done, because what I need to do after that is basically for the migration tooling. I need to improve the API a little bit, just make it more like simpler and yeah, just simpler basically. But there is no change in the implementation detail. It's just same thing. So it's just about renaming a few enumerator members and function names here and there. And after that, I would like to add more like functions to the macros, especially like macro unit tests rather. Then maybe I change feed and blah 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 blah. But every other stuff is minor. And in fact, apart from the migration tooling, that I would like to just change the API a little bit, because I don't want to have to change that after releasing stuff. Every other stuff could be done pretty much subsequently, but I'm gonna do it already, right? So I don't know. What do you guys think? I I think I'm just gonna call it a day, a night, a day, because I need to take time to to actually think it's true. And the string. Wrap the string. Parse. I'm just gonna try this real quick. Field type and field type parser. Let's make this load and expected identifier. Why is not getting an identifier right there? Oh yeah, so of course I need to also parse that. Let's see. How do I get there? Yeah, it looks promising. Yeah, seems like this has been parsed. But anyway, I will continue with this later. I need to take some rest, so I'm gonna recover. I love you guys. Continue this later. I'll see if I can work on this, and if I'm gonna come live on stream to resolve this issue. Otherwise, I might just do it off stream. But whichever way, I hope you guys have been okay joining my recovery stream. I love you guys. Take it easy. Love, peace, everywhere. Unity. Namaste. Tanya Bot. Thank you. Merci beaucoup. I love you guys. Have a good one. Oh, we're joining again later. Coughing.